In this section, we will explain a gist of the methods by which we could add our own shader codes to the engine and see their results in real time. We will also go through the basic features which Unreal Engine already provides to us, then its structure, and finally, we will write our own first code. Generally, there are 3 ways to add our own shader code to the Unreal Engine. The first one is using a custom node and writing down codes inside it from the material editor. Second is where we write down the code as a text file by an external text editing software or IDE, then we establish the link of the file to the custom node via material editor and use it. Finally, the last method where we type the code in the external software, then make it available to the source code of the engine so that it could appear in the material editor as a function node. As it seems to be, the last one is the most advanced one, and you also have to learn C++ coding and handling of the source code in order to do it. Eventually, we will go through all of these methods, but as we have just started to take off, we will use a 4th method. In this way, we simply type our code to a simple text editor tool, then we copy and paste it back to the custom mode of Unreal and use it. Now we will get into the Unreal and start writing our first code. We will start with the first method mentioned earlier. Let's right-click on the material graph and type custom. It will open a green node named custom. This is node where we will be spending time for now. You might need to drag the details panel to get a clearer view of the properties it has. By default, we could see there is already a code typed inside the code section, and that is 1. The next is output type, which means what type of end result we are expecting to get out of it. As you click and look into the drop-down, you will see options like float 1, float 2, float 3, etc. All of these have decent technical meanings. We are going to explain these as easy as possible. In computer graphics, an image is presented by pixels, and these pixels also have red, green, and blue values. These are called R, G, and B according to the mentioned order of the previous line. Now, when you zoom in into any footage, you could see the pixels have different colors, combined by these R, G, and B of different values. Hence, to represent the image we see through our eyes, inside computer we need a minimum 3 different layers of pixels where each layer presents a shade of different values of R, G, and B. Now, these values are not a complete integer, that is, a total 0 or 1. Meaning, for the shade to form, each layer need to have anything between 0 and 1, such as 0.23 or 0.002, or even 0.9547. For our computer, we need to use a class which can present decimals, which is the type float. So when we use 2 layers of those float, it becomes a float 2 type, and when there are 3 layers of info, it becomes a float 3 in which R, G, and B combine together. To sum up, a float is a type which can represent decimals. A float 2 has 2 layers of float info which are R and G, and finally a float 3 is a set of 3 layers of individual float values which are G and B. Now, let's us go back to the material editor. On the custom node details, the next thing that you should notice is the section named description. This naming is, however, a bit awkward. This one should be called title instead, as the text you put here will be the name of this custom node displayed in the graph. You can try to name it as you wish, even you could have typo mistakes, and it won't affect your actual code. We will give a name which is relevant to this video. The later one is the input section. Here, when you click at the plus sign, you add the dots at the left side which expect to be connected to something in the graph. You must name it as one of the variables from your code section. If you name it and don't connect, it will show you error. We will see usage of this on the next videos. It's the time for the output section. Just like input, if you click on the plus sign, you add more outputs. This is extremely useful when your function generates different results and you want to use them later. As you could see, for each additional output, there is an extra section which is a drop-down list. Here you are supposed to pick and tell the material editor which type of output it's going to be. The last two are define and include section. These will be covered on the intermediate section of this course. Now, before plugging the custom node to the material node, we will change the type to unlit mode. We do this to make the material code less heavy, and this also helps to reduce the code compile time, meaning we can test our results quicker. We also recommend you to do the same when you are testing something new code. Once we are done, let's connect to the material master node. We could see now the shader ball has turned into white. You may ask why it's white when we haven't added any code there yet. This is because by default there is 1 in the custom node, and also the output type is set to a float 3. That's why the shader ball is white, as the code is giving off a value of 1 in all channels, red, green, and blue. If we type 0 instead of 1 in the code section, it will make the ball black. While we could have just checked our codes this way, but we won't be able to inspect the results or debug it in an efficient way. That's why we will introduce another extra node. Let's right-click and type debug scalar and press enter. It will spawn a node. In parentheses, there are similar nodes for float 2 and float 3 type of results. However, for our current usage, we will use the scalar one. Let's plug a constant scalar on this node, and you could see the value is being displayed at the shader preview mesh. As we have told earlier that every pixel on our screen is a combination of 3 channels, RGB, these nodes will be a great tool for us to check our codes. We will connect our custom node to the debug scalar node. We will also change the type to float 1. Now we could see that the result of the custom node is being displayed. We will start writing our first code, that is, a simple math equation. Once we are done writing, we can see that the results are there and we are done. So, let's sum up. We were able to know about custom node, we were able to write down a very basic math code into there, and finally, we were able to know about how we could efficiently check the results of our code written inside the custom node and see it in the material editor. That's it for this video. Let's move into next one. Click on subscribe. Make sure to hit the bell icon below the video, as there will be a lot of videos. And you will get notified about their release only when you hit the bell icon.